Welcome back. If you've just joined us, we're doing some maths literacy. If you've been with us for a while, well, good for you, because I'm sure you've learned quite a bit already. Okay. My next question we're going to look at, and for those of you who, let's try that again. For those of you who have just joined us, we are busy going through the Natal prelim paper that was set earlier this year. And we're looking at paper 1, right? And what I thought we'd tackle now is we're going to tackle a question on shape and measurement. And it came from the question 3 that was set in the KwaZulu-Natal paper. So let's have a look at it. The following model was designed by a team of learners. They used the rectangular prism as the base. The length of the rectangular prism is 100 centimeters, breadth was 30 centimeters, and the height is 0.4 meters. On top of the square prism, they placed a cylinder with a diameter of 30 centimeters and a height of 90 centimeters. Now, my giddy aunt, that is so much information to try and read and focus and get into your mind. It's a nightmare. But this person who set this paper was very kind and actually drew a model of all this information. Okay? So although there's a whack of stuff here, let's just look straight at the diagram. And there it is. Okay? So I have a little kind of weird shaped box here. All right? And on top of it, I have this cylinder. We have a length of 100, a width of 30, a height of 0.4. Hello. Let's just have a look here quickly. What do you notice? Okay. Everything is in centimeters except this guy over here. It's in meters. Now, that's not nice of this examiner to have done that. He's trying to trick you, okay? He's trying to see if you're going to pick that up. So, be very aware. Here's a huge hint. When you do any question on shape and measurement, always make sure your units are the same. So, if you're dealing in meters, make sure everything's in meters. If it's centimeters, make sure everything is centimeters. Okay? If it's millimeters, everything in millimeters. So straight away looking at this, I can see here that I've got meters, everything else is centimeters. Can you see that? Okay? But this guy, oh my goodness, I've just got rid of the entire question. Let's try to find it again. Here we go. So this question over here, this part of the question anyway, the height is in meters. So I'm going to say, let's get rid of that. Let's change meters to centimeters. So I ask myself, how many centimeters in a meter? And there are 100. So because there are 100 centimeters in 1 meter, I'm going to take my 0.4 and multiply it by 100. So we've got 0.4 and we're multiplying it now by 100. Okay? And I'm going to land up then with 40 centimeters. Okay? Now, we've sorted that out. Everything now is in the same unit. Because everything's in the same unit, I can now begin with my questions, and I'm not going to make a careless error. First question says, calculate the surface area in meters of the rectangular base. Okay, now, my giddy aunt, what I've actually gone and done is I've changed my meters to centimeters. And that's not a train smash. But it just means that when I calculate everything in centimeters, I've got to remember to convert my final answer back to meters. Now, folk, I'm going to say this. If you read a question and it says, I want my answer in meters, then straight up front, change all your units to meters, because then you are not going to make a silly mistake. So what I'm going to say is this thing over here that we changed to centimeters, let's leave it as meters. Let's change that to meters, and I'm going to get 0.9 meters. Why? Because there are 100 centimeters in a meter, and if I divide that by 100, I'm going to get 0.9. When I divide this guy, I'm going to say that's 0.3 meters. This guy over here is 0.3 meters. The length, let's just go down a little bit. Instead of being 100 centimeters, what are we going to say? We're going to say it's 1 meter. Now that I have all my units in meters, I can now answer my question, which stated, what is the surface area of my box? Okay, so what's the surface area of the rectangular base? And they want the answer in meters. All right, now, I'm not sure how your teachers marked this question, because there are two things that worry me. The first is this, that I always say that at the end of the year, and please understand that the people who set these prelim papers are not the people who set your final paper, okay? But at the end of the year, you will never get given a question, okay, with information that's not needed. And if we give you information, you will need it for that question, right? And I always say this to my guys, and I've said this on this program over and over and over again. As an examiner, we do not wake up at 2 in the morning and think, let's think of some weird formula we can slap into a question and confuse everyone. We don't do that. Examiners are very nice people, okay? We'll only put stuff in that you need for that exam question. So here's my problem with this question. My problem is this, that it says use pi is 3,14, but there's no formula with pi in it. The next problem I have with this question is this. Are they asking for the surface area of the box without that cylinder, or are they asking for the area of that box with the cylinder on top? Because we're going to get two different answers. Now, I'm going to presume that they are asking me for the surface area of the entire box, excluding the part where the cone is fitting on. Okay? So, how are we going to do that? Well, here we go. Firstly, the surface area of the rectangle. Right. The other little problem with this question says calculate the surface area. Folk, area, what is our units for area? If I asked you for perimeter, you would say your perimeter is so many meters. If I said, what's the area, you would then say your answer or your units would be meters squared. Volume would be meters cubed. So let's go back to this question. Calculate the surface area in meters. Don't fall for this, eh? It should be meters squared because we're dealing with area. So, surface area of the whole rectangle equals 2 times the length and the breadth plus 2 times the breadth and the height plus 2 times the length times the height. Right, let's just find all these measurements. The length of the box, 1 meter. So every time there's a length, I'm going to put 1 meter. And there's a length over here, 1 meter. Now, the next thing we're going to do is say, what is my breadth? 0,3 meters. So my breadth, 0,3 meters, and I have a breadth over here of 0,3 meters. Right. What is the height of my box? 0,4 meters. So my height, 0,4 meters, and my height, 0,4 meters. So all I've done is I've looked at my diagram, I've looked at the equation, and I've said, right, the equation says a length must come in here and here. I've gone to my diagram, my length is 1 meter, let's slap it in, here and here. My breadth must come here and here in the formula, looked at the diagram, got the breadth, slapped it in here and here. Okay? The height goes in here and here. What's the height? Let's put it in there and there. Just simple substitution. Now that I have all of that, I can now use my calculator and try and find out the actual answer. So that's exactly what we're going to do. And I've just moved the screen down so that I can read everything on my calculator. So let's do that quickly. Okay, let's clear that. So I've got 2 bracket 1 times 0.3 close bracket plus 2 bracket 0.3 times, and what's it times? 0,4. So let's just do that, times 0.4 close brackets plus 2 bracket, and what do we have over here? We got 1 times 0,4. So 1 times 0.4 close brackets. Before I push equals, let me just stress this. what I've got on my paper, I'm pushing into my calculator. So as I read it on my script, so I'm pushing it into my calculator. And if I do that, I can't go wrong. My calculator should give me the right answer. Equals, and we get an answer then of 1,64. So my answer is, let's just go here, 1,64. 1,64 what? 1,64 meters squared. Why squared? Because we're dealing with area. So I've got 1,64 meters squared. Are we happy? But we haven't finished, because that's the surface area of this whole box, including the area that my cone is sitting on top. And I don't want to include that area. I want to pretend that that is not part of the surface area of my box. I've got a box, I cut a hole in it and shoved a cone in, okay, or cylinder inside it. So let's take that out. How are we going to take that out? We've got to find the area of that circle. Now, area of a circle is equal to pi times r squared. Pi is 3,14. Why? Because the question says use pi as 3,14. Now, if we look here, we can see that I have a diameter of 0,3 meters. Okay, so my diameter is 0,3 meters. Now, folks, what is the difference between a diameter and a radius? The diameter is, if I've got a circle, the diameter will be from the one side of my circle to the other. That's the diameter. What is the radius? The radius is from the middle of that circle to the circumference of that circle, okay, to the edge of the circle. Now, diameter from the circle edge to the middle, from the middle to the circle edge. That's the diameter. In other words, it's 2 radiuses, or 2 radii. So, if I have a diameter of 0,3, my radius must be half of that. What is half of 0,3? Let's go for it. So if you don't know how to do that, let's just do it straight on a calculator. 0.3 divided by 2 equals, and 0,15. So 0,15, but not just 0,15, but 0,15 squared. Oi, 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 oi. Every year, when I mark matric papers, without fail, people will say, the formula for the area of a circle is area equals pi times r squared. And they write that down in the formula. And they're absolutely right. And then when they put the values into the formula, they say equals 3,14 times whatever the radius is, in this case 0,15, and they forget to square it. Now, folks, they know what they're doing, but they make silly mistakes. Don't you do that at the end of the year. So it's 3,14 times 0,15 squared. Remember the squared equals. Again, our calculator comes up, and we're going to just do that. 3.14 multiplied by 0.15 squared equals, and there's my answer of 0,07065. I'm going to round it to 2 decimal places, 0,07. So my answer then equals 0,07. What? Meters squared. Why meters squared? Because we're dealing in area. So let's see what we've worked out at the moment. We've got the surface area of the whole box. We've had to drill a hole into that box. Okay, the area of that hole is 0,07 meters squared. So we're going to take the whole box and subtract that little area, okay, of the circle. So let's just do that. We're going to say, right, so the whole area was 1,64 meters squared minus the little circular area of 0,07 meters squared, okay, equals, and then again, simply with our calculator, we're going to say, right, 1.64 minus 0.07 equals, and we get an answer of 1,57. So it's 1.57 meters squared. Sure, that was a lot of work, okay? And after all that, I think we actually need a break, okay? So you go off, get a drink of water, splash your face. We only got 15 minutes to go. See you soon.